background about this study. It was done 12 years ago by another JSU graduate, Daniel Carver. And what he found was impairment in stream benthic invertebrate community assemblages, as well as a degradation in water quality. However, we know that there are three things that dictate stream health. There is a biological component, a chemical component, and as well as a physical component. And Carver addressed two of these. What he failed to address was if the physical habitat within Choccolocco Creek was also undergoing degradation. And degradation within Choccolocco could be the result of land use that is aggregated along the stream. What you're looking at are aerial maps of the Choccolocco Basin over a 15-year period from 1992 until 2006. The areas in pink or red are urbanized areas, specifically industrial, residential, and commercial land use. The areas in brown are agricultural land use, specifically row crops. The areas in yellow are pasture lands or open areas, and the areas in green are forested areas. And you can see that over this 15-year period, there was some changes in land use within the basin, and we would have expected these changes to have continued over the past 6 years. So there are several things that we know about streams and urbanized and agricultural landscapes. Streams that are surrounded by agriculture tend to have increased nutrient loading, increased turbidity, higher levels of embeddedness. Urbanized streams tend to show changes in hydrology, increased flashiness, as well as higher levels of embeddedness. And Carver saw all of these things within Choccolocco, but he really didn't explain why. These are our 5 sites along Choccolocco. They correspond with the points on the map. Site 1 is located in the Tolly-Jordan National Forest and receives the least anthropogenic inputs. Carver used this as a reference site because it was predicted to be the least impacted. Site 2 is at Joseph Springs Motorway and is surrounded by logging and agriculture. Site 3 is just below the Oxford Exchange. It actually had construction going up along both sides of the stream while we were completing our survey, and Site 3 was predicted to be the most impacted. Site 4 is located in Mumford, Alabama, and Site 5 is Jackson Shoals in Lincoln, Alabama, near the Talladega National Speedway. So I actually had 2 questions for my research concerning Choccolocco, and the first was, have the 5 sites along the creek changed in the past 12 years? Carver sampled from October 1998 until 1998 until January 2000. My survey ran from April 2011 to April 2012. In order to be able to make comparisons between our surveys and standardize all of our results, we only used January, April, July, and October results in our analysis. We repeated all of Carver's sampling efforts. For the chemical component, we tested temperature, pH, total dissolved solids, conductivity, and dissolved oxygen. For the biological component, Carver used EPA rapid bioassessment protocols. And he did this within the rippled areas, which tend to show more diversity than pooled areas of the stream. EPA protocols allow for a way to standardize sampling methods so that comparisons can be made between surveys, and it also offers a time-efficient and cost-efficient way to biological sample. We took 6 kick samples at each site during each sampling event. They were brought back to the lab and identified to the family level, just as Carver had done for his survey. He then was able to calculate an index of biotic integrity score, or an IBI score, using the 8 following metrics. So that we can make comparisons between our surveys and IBI scores, I used the same 8 metrics. And these were the 8 metrics designated by ADM to determine IBI score in 1999 when Carver was doing his study. So let me take a minute and explain what each one of these metrics represent. Family richness is the number of families within a sample. Higher levels of diversity indicate better stream conditions. The biotic score, also known as the Hilsenhoff biotic score, takes into consideration tolerance values of taxa found, the number of organisms found in that taxa, and compares it to the total number of organisms in a sample, so that each taxa is given a tolerance value ranging from 0 to 10. with 0 being your most pollution-sensitive taxa, 10 being your most pollution-tolerant taxa. Based on that number, you multiply it by the number of organisms you found in that taxa, and you divide that number by the total number of organisms in the sample. You will get a value ranging from 0 to 10, and this allows you to classify the water quality at each site ranging from excellent to very poor. The ratio of scrapers to filter collectors is a feeding group metric, and this allows you to see if any changes have occurred within the community food base. EPT stands for Ephemetra, Plecoptera, and Trichoptera. These orders of invertebrates are usually what we consider to be pollution-sensitive taxa. Your chironomids are generally considered to be pollution-tolerant taxa, so that in an ideal stream setting, you would have an even distribution of EPT taxa and chironomids indicated by a value of 0.75. Any variation from that value indicates environmental stress. Percent dominant taxa is the number, is the percentage of the total number of organisms in the family in the sample's most abundant family. Relatively few dominant taxa in a sample, once again, indicate declining water conditions. Again, EPT, Ephemetra, Plecoptera, Trichoptera, these are your sensitive taxa. So if you have more sensitive taxa at a site, that's usually indicative of better conditions. The Community Loss Index takes into consideration taxa found at the reference site and compares it to taxa found at the study site, so that higher values indicate that more taxa were lost between the reference site and the study site. And higher values wouldn't be indicative of environmental stress. Percent shredders is another feeding group metric. Shredders rely on leaves and plant debris as their primary food source, and a higher number here indicates optimal conditions. Each one of these metrics were calculated either based on a ratio of the study site to the reference site to the study site, the actual percent contribution, or a comparison to the reference site was already incorporated into the indices. And they were given a value based on the percentage you got for each metric. It was given a value of 6, 4, 2, and 0. So we did this for all sites, for all metrics. Those scores were then totaled, this was for the reference site as well. The total score of the study site was then divided by the total score of the reference site and multiplied by 100 to give you another percentage. Based on this percentage, we were then able to assign a biological condition to each site as non-impaired, slightly impaired, moderately impaired, or severely impaired. For our results, this is the results of our water quality comparison. Panel A is temperature, Panel B is dissolved oxygen, Panel C is pH, Panel D is total dissolved solids, Panel E is conductivity, and once again, we added total suspended solids to our survey, which is an indicator of turbidity. Bars shaded light blue are the 2012 results. The bars shaded dark blue are the 2000 results. You can see that temperature, pH, total dissolved solids, and conductivity all increased moving downstream, and they also increased when comparing the 2000 and 2012 survey results. Dissolved oxygen decreased moving downstream and also decreased between the two surveys. Total suspended solids, our values were pretty much similar for sites 1, 2, 4, and 5. However, the site 3, which is just below the Oxford Exchange, that was predicted to be the most impacted, had a higher value of total suspended solids. And this is just a picture of a filter paper. The way we collected total suspended solids, we ran a liter of water through a pre-weighed filter paper. This filter paper has actually become clogged from all the sediments that were suspended in the water column. The picture on the right is a graduated cylinder showing you this was a water sample collected from site 3 after a rain event, and this is just to show you the turbidity in the water there. Again, our IBI scores were calculated from the 8 metrics and based on a percentage of the reference score, so that the reference site scored 100 in both surveys. Just to kind of give you a comparison here, Site 2 scored a 91.3 in 2000 and was classified as non-impaired. However, for my survey, Site 2 dropped to a 77.27 and was classified as slightly impaired. Site 3 followed similar suit and dropped from an 82.61 to a 72.73 and was classified as slightly impaired. What's interesting between these two results is that Site 4 scored the lowest IBI scores in both surveys, and Site 5 showed improvement in IBI scores in both surveys. This is just to give you a comparison of taxa found in 2000 versus taxa that I found in my survey. Again, Ephemetra is your mayflies, Plecoptera is your stoneflies, Trichoptera are your caddisflies, pollution-sensitive taxa. And these are the different families that were found within each one of those orders. And you can see that we were relatively finding similar taxa between the two surveys. We didn't really have anything that surprised us. We found pretty much the same organisms. Same thing here. This is your Coleoptera, Odonata, and Diptera, and the families that were found between the two surveys. We did find other invertebrates. We found the oligochaetes, bivalves, and other organisms, but for presentation purposes, these were the 6 main orders that stayed pretty consistent between the two surveys, so we wanted to show you the similarities of taxa found. So for our discussion, has the biological creek changed in the past 12 years? Yes. We saw increases in temperature, pH, total dissolved solids, and conductivity between the two surveys, and as you moved downstream. We saw decreases in dissolved oxygen as you moved downstream and between the two surveys. You would expect to see these trends, this increasing as you move downstream and for the dissolved oxygen decreasing as you move downstream, in a non-impaired stream though. So water quality alone is not a good indicator of stream conditions. And any variation between our water quality results and Carver's water quality results may be the result of sampling error, for sampling effort. He sampled within the rippled areas of the stream. Due to logistics, I had to take my water samples from bridge crossings near the rippled areas, but bridge crossings tend to be cooled areas where you will see higher temperature, higher pH, higher conductivity, higher total dissolved solids, and lower dissolved oxygen levels. So that may explain some of the variation that we are seeing just based on water quality. However, from the biological side, we did see impairment increase at sites 2, 3, and 4 with improvement at site 5 in both surveys. So improvement at site 5 could be due to the inclusion of large shoals and the availability of microhabitats, which have been directly linked with increases in diversity, which would result in higher IBI scores. So for my second question, I wanted to see if invertebrate diversity within Choccolocco was being driven by habitat heterogeneity. Habitat heterogeneity is a variation in factors associated with the stream's physical habitat. For this study, we looked at 3 different factors: particle size, embeddedness, and moss. Variation in particle size is an indicator of a heterogeneous system. At site 3, you can see all the fine sedimentation here. We wouldn't have predicted that site 3 would be a very heterogeneous system. It appears to be homogeneous. Site 5, however, has the inclusion of large boulders, large cobble, small cobble, and some fine sediments. So we would have predicted that site 5 would have been a heterogeneous site. Embeddedness, which we also measured for, is negatively correlated with habitat heterogeneity, so that higher levels of embeddedness indicate a more homogeneous system, because embeddedness is usually the result of sedimentation. And you can see here that the rocks appear to be about 50% embedded in the sediments. Moss is considered to be positively correlated with habitat heterogeneity because it increases surface area for the invertebrates to inhabit. So for our methods, for our biological samples, we used a Hess bottom sampler, and you can see a little corner of it here. It kind of looks like a bucket. But this offers us a way to quantitatively collect samples because we know exactly how much of the bottom we're sampling. It's 0.3 meters squared. We took 3 samples from each site for each date, so the N equaled 25. We then brought all of those invertebrates back to the lab and identified them to the genus level in order to give us a better resolution of the taxa found within Choccolocco Creek. In order to test to see if Choccolocco Creek had a heterogeneous system, we used pebble counts where 100 rocks were randomly selected from each site for each day, and we measured for size, percent embeddedness, and percent moss. We assumed that each rock had the shape of a cube, which is 6-sided, so that 15% coverage would indicate one face of the rock was either embedded or covered with moss, depending on which one we were talking about. We assessed our invertebrate data using 2 different diversity indices, the Hilsenhoff Biotic Index, which once again takes into consideration tolerance values and the abundance of organisms within that taxa compared to the total number of organisms in the sample. And you can see that for the most part, we had relatively similar values at all sites during all sampling events. Simpson's Diversity Index takes into consideration richness and evenness of taxa found within a sample. Values closer to 1 indicate greater diversity. And here again, you see a lot of similarities in our results among sites and throughout our sampling dates. This is just to give you a comparison of our habitat variables among sites. So that panel A is moss, panel B is embeddedness. The y-axis in A and B represent 100% of the rocks collected. So that you can see here, site 2 had higher levels of moss than the other 4 sites. Panel C is particle size. And for the purpose of this presentation, we have simplified the y-axis into 5 categories: silt, gravel, cobble, boulder, and bedrock. And the substrate within Choccolocco Creek pretty much falls out between cobble and boulder. But we did see variations in the fine sediments, the fine silts. Again, for example, site 1 had very few fine silts. Site 3, on the other hand, again, a lot of fine sedimentation at site 3. In order to see if Choccolocco Creek is indeed a heterogeneous system, we used previous research to determine this, and what we did was, based on Cardinal, we took the 84th percentile of particle size of rocks collected, divided it by the 50th percentile of particle size of rocks collected, and it gave us a ratio that allowed us to make assumptions about heterogeneity. Values greater than 2 were indicative of a heterogeneous system. Using this model, we did the same thing for moss and particle embeddedness, except for these 2, we used presence-absence ratios. For moss, which is positively correlated with habitat heterogeneity, we said values greater than 2 for the presence-absence ratios. It indicated a heterogeneous system. Particle embeddedness, which is negatively correlated with habitat heterogeneity, we used presence-absence value ratios that were less than 2 as indicative of a heterogeneous system. And these are our results. So that you can see each site and each sampling event, and these are the ratios that were calculated. Again, size was from the 84th percentile divided by the 50th percentile. Embeddedness is presence-absence, and moss is presence-absence. And all our values were less than 2, indicating that Choccolocco Creek is indeed a homogeneous system. For our second approach, we use principal component analysis to account for the lack of independence among these variables. PCA generates a variable that represents the contribution of moss, size, and embeddedness ratios. We termed this variable the heterogeneity index for this study. Then we were able to make a comparison of the heterogeneity index and biodiversity along Choccolocco Creek using linear regression. These are our results of the PCA analysis. So PCA run 3 principal components to see where the variation was occurring within our samples. And you can see that PC1 explains 88% of our data, with moss being the greatest contributor to variation. And that makes sense because back on our ratio slide, moss had the greatest range of ratios, the most variability in ratios. So we used PC1 and we regressed our diversity indices against PC1. Simpson's Diversity Index is on the top panel. Pilsenhoff Biotic Index is on the bottom panel. But you can see there was no significant relationship between diversity and habitat heterogeneity within Choccolocco Creek. So for our discussion, diversity positively correlated with habitat heterogeneity. Well, according to our results, Choccolocco Creek is a homogeneous system. And homogeny is the direct result of changes in hydrology induced from land use, such as the construction of roads and urbanization, deforestation, the construction of reservoirs, and the degradation of stream banks. All create a homogeneous system, and all of these are present within the Choccolocco Basin. Our linear regression of diversity, again, against our PC1 habitat scores, did not show a significant relationship between heterogeneity and diversity. So, to explain this, homogeny among sites may explain the similar levels of diversity found at each site. And even though our IBI scores show that Choccolocco has undergone little impairment between 2000 and 2012, relative homogeneous diversities in habitats may occur prior to detectable losses in intolerant taxa that would result in your lower IBI scores. So for the future of Choccolocco Creek, homogeneous diversities in habitats may be indicative of greater susceptibility to future stressors within the basin that will result in your declines in both IBI and diversity indices. Thus, the inclusion of monitoring changes in the physical habitat heterogeneity and diversity are suggested with IBI monitoring to better understand how streams respond within their basins, to changes within their basins. I would like to thank JSU and the Legacy Foundation, as well as the Alabama Academy of Science, for funding my project. I would also like to thank my field help. This was a big project, and I couldn't have done it without you. Daniel, Lindsay, thank y'all. To my undergraduate students that stepped up and volunteered for this, Mariah, Rebecca, again, thank you. And to my family for their support, being out there with me. Jesse, Daddy, Meg, thanks. And I would like to thank my thesis committee and the Department of Biology for their support. And I would like to extend a special thanks to Dr. PJ for encouraging and keeping my head on straight the past 2 years. I've needed her every step of the way. Thank you.
Well, are there any questions?
I'll ask one.
Yeah, go for it.
You mentioned that you were using the IBI from 2000, the same one that the previous study used, correct?
Let me get it. Yeah. The 8 metrics, yes, that he used from ADM 1999. Let me find them there.
Just out of curiosity, have there been any changes in that since then, 2012, as far as how they review their IBI?
Yes, I'm sure there are.
Okay.
We just, in order to make a comparison between his survey and ours, we used the same thing that he looked at to calculate our IBI score.
Oh, somebody.
I'll ask.
Did you collect data that would work with the current IBI scoring system so that if somebody repeated this 10 years from now, that they would be able to compare their apples to your apples, even though you compared oranges to oranges in this study?
Yes. My data, all you have to do is go back and calculate the metrics that ADM would be using now. So, yes.
See an increase in temperature over time, and it makes sense that you should then see a decline in dissolved oxygen over time as well. Do you have any idea why you see an increase in temperature? I'm intrigued by, is there a chance that your reducing canopy cover, that's going to have the effect of increasing temperature?
Well, the stream has definitely seen some changes in the vegetation alongside it. But I really think the differences that we are seeing in temperature are are due to our sampling efforts. Like I said, due to logistics and going out there, sometimes I was by myself, we took it from bridge crossings.
Yeah, and that would
because
be-
some of the sites were kind of difficult to get in. But I think that's where we're sitting. I think that's where the variation in temperatures is being shown there.
Since he brings that up about the oxygen, if you convert your oxygen to percent oxygen in the water, because the amount of oxygen in water is directly related to what the temperature of the water is, I wonder if your values would come out closer to being the same. You had a higher temperature, but you went to your percentages, how that would change.
I would have to do
Yeah,
that.
you have to,
I would have to do that calculation.
Yeah, I was saying that would be something that might be cool to look at.
Holly, okay, you took all of those, okay, can you back up to that, the slot, yeah, there you go. So you take all those and you're gonna create a new school.
Right.
Yeah. And then-
Based on the percentage, or the percentages that we use to calculate. So like family richness was a score given based on the ratio of the study site to the reference site. So we took whatever family richness was at the study site and divided it by the family richness at the reference site and multiplied that by 100. And that gave us a percentage, so that if it fell out to be 80% for that metric at that site, it got a score of 6.
Okay, so you saw, okay, so you did this for the old data and you did it for the new data, right?
Yes.
Okay. And there were some changes.
There were some changes. Let me. Right here.
Okay. There's a lot of different things that go into the numbers that ultimately generate there was a change or they're not.
Right.
Was there anything that really jumped out at you and said, gosh, it's a change in EPT or it's a change in something that might have contributed more significantly to the
I
final
think our
results?
family richness was one. Percent dominant taxa was definitely one. Especially at like site 4, Carver samples really had relatively few Herodenia in them. My samples at site 4 were covered over with leeches.
What's your favorite part, most interesting thing about this study?
Being out in the field. The lab part was awful, but being out in the field was great.
Maybe it was finishing it. That was
Yeah.
probably. What snails did you find?
Chlorocerids, we found Limnia, hydrobiids, name with O. I don't think we had any. For the most part, I think it was a Limnia.
Little viviparous. Now some really cool looking left-handed viviparous in that stream. That's very odd. There's stuff in the Bible.
Yeah.
Just curiosity, when you go out and you collect, how many of these things are you looking at when you come in the lab for a site?
Oh.
Just a ballpark, I'm just kind of
A
curious.
bunch.
Yeah, I knew the answer would be large, but I just don't have a clue.
So we took 6 kick samples at each site. So a kick sample, see if I can find a picture of my net
Right,
here.
right.
So the substrate in here was all dumped into little baggies and brought back and had to be picked through. So one kick sample would probably get you 4 or 5 of the little twisty, I don't know, look like a sandwich bag. And the Hess sample would be about the same. You would get 3 or 4 from each sample collected. So there were a bunch.
You get several hundred at least out of each.
And how many organisms total did you have to look at in ID? I think that appears somewhere.
I don't know if I had it in here. It was well into the thousands.
Did you have that number?
No.
It's in this
I didn't
right
think so.
here.
Yeah. It was well into, I'm not sure, but it was well into the thousands.
It'd be bigger than more than that.
Impressive number.
Well, thank you very much, Holly. It was very informative, and I hope all of you learned something about Choccolocco Creek. So, very good.